So here is one modestly more involved claim than the previous two. So let's let A sub n be a convergent sequence, and let's assume A sub n converges to A. Let's prove that absolute value of A sub n converges to absolute value of A. So this is going to look slightly different than the stuff on the previous page, because I don't know exactly what the sequence A sub n is. One thing I'll say is whenever you don't know what the sequence is, you will not have a choice of big N. You'll not be able to fix a choice of big N, as we did on the previous page. Instead, we'll somehow have to use the assumptions to come up with a choice of big N. So that's how things will go. But other than that, it's an epsilon n proof just as those on the previous page. So let's write down our assumptions. Let's let A sub n be a convergent sequence. Let's let A be equal to its limit. We need to prove that the absolute value of A sub n converges to absolute value of A. So how is that going to go? Well, we'll start by considering any epsilon bigger than 0. And, well, after you come up with a choice of epsilon bigger than 0, we need to come up with a choice of big N. We won't be able to do like we did on the previous pages, though. We won't be able to get an explicit choice. But we do know something really strong. We know A sub n converges to A. So let's use that. Since A sub n converges to A by assumption, there is some epsilon bigger than some big N such that for all little n bigger than big N, it follows that absolute value of A sub n minus A is less than epsilon. And notice that doesn't even need to be an epsilon. That could be any positive number, right? Oftentimes we'll see examples where really what you want here is like an epsilon over 3. But, well, we'll see if this choice is good enough. And sorry if I seem distracted. There's like a really big bug on the other side of the room. I'm not going to show you. So let's take a look at this. There's what we've assumed. We need to show something about absolute value of A sub n. And we need to say something. In fact, let's go back to scratch paper. We need to say something about the absolute value of A sub n minus the absolute value of A. Now, well, let's see. There's like a second version of the triangle inequality that's pretty useful in this kind of situation, which says that if you take the absolute value of the difference of two absolute values, this is less than or equal to just the absolute value of the difference. So there's something super useful, right? Because we know that that's as small as we want. We know that that's less than epsilon. So I think this tells us just everything. So let's use that triangle inequality. So by the triangle inequality, and I think I called that the triangle inequality version 2 in the notes on containing the triangle inequality. Absolute value of the absolute value of A sub n minus the absolute value of A is less than or equal to the absolute value of A sub n minus A. But by, well, right now an assumption, absolute value of A sub n minus A is less than epsilon when little n is bigger than big N. So for all little n bigger than big N, transitivity implies but wait, that means that for every epsilon bigger than 0, there exists m big N such that for all little n bigger than, sorry, everything was off the screen. So for every epsilon bigger than 0, there exists m big N. We came up with a choice of big N, so that for all little n bigger than big N, this difference is less than epsilon. So limit of absolute value of a sub n is equal to absolute value of a, as we claimed. All right, well, excellent. So this was the several videos that I recorded all in a rapid succession. So I may have seemed slightly tired by the end of it. Hopefully it went okay, though. I look forward to seeing you in class again. This is during the summer, so I haven't seen you yet. I hope these videos are actually being useful. Bye.